Hello everyone. So my name is Joseph Cameron, and in this video I'll be showing a short demonstration of my final year dissertation project at the University of Glasgow. So first things first, the project is titled Using Machine Learning to Understand Knot Topology. In this project I've built a classifier that can classify knots from images, and I'm now going to show you all the scripts that are involved in, first of all, training the convolutional neural network, and then later in the video I'll show the iOS app that I have made to become a usable interface for the convolutional neural network. Okay, so let's get started. Okay, so this is the Knot Classifier script. The first important thing to mention is the purpose of this script. So here we give it the location of the dataset, and we give the train and validation directories. And then after importing Keras, we can train this data on convolutional neural network model architectures. And we can also apply data augmentation if we wish. You can opt to apply flags for the size of the convolutional neural network model that you would like. And then we simply save the trained model in its entirety, and we also save a TSNE plot, training history plot, and confusion matrix plot. And these are very useful for evaluating the classifier. So now let's go back to the terminal and let's run this script. So if I just run this, it will use the medium convolutional neural network architecture by default, and it won't apply data augmentation. So you can see Keras is using a TensorFlow background. You can see that we're using the medium model architecture. The model summary is printed out here. And you can see that the training begins. Now if I just stop this, I can quickly show that by adding this A flag, you can now also use data augmentation. So before, we were not using data augmentation. Now with this flag, we are using data augmentation. Similarly to the data augmentation, you can also specify what size of network you would like to use. So, for instance, -L is for the large, and -S is for the small neural network. Just to show, we put -L in. We are now using the large CNN model architecture. Now then, let's run the medium model architecture with augmentation. And now this will take a few minutes to train. Okay, so our classifier has now finished. Sorry, not classifier.py is now finished training. And you can see here the new files it is created. So this is the model here, first try.h5. Obviously, you can specify all the names for these files. It doesn't necessarily have to be the same as this. But yeah, these are the files that it generates. So this is the model. And then here you can see the TSNE plot that it generates. You can see some nice clusters here. Yeah, the goal of TSNE is essentially to reduce the dimension of the data, in this case to 2 dimensions, so that we can see how the data is being grouped, etc. So you can see that. We've also got a training history. So you can see in this specific run, it was quite good. We reached about 60% validation accuracy and close to 50% training accuracy. This all depends on many things, how many epochs you run for, etc. You can also see that the loss was quite... the validation loss and the training loss both decreased at the same rate here, so there's little overfitting, which is quite nice. And there's also a confusion matrix that's generated. Obviously, every run will generate a different confusion matrix, but just to clarify, these are the files that are generated. Okay, so that's the training of the neural network, convolutional neural network. Now let's talk about the app. So the application is here. It's called the Knot Classifier. Let's open this up in Xcode because it's an iOS app. Here we go. So this is a really quick view of what the project looks like in Xcode. Essentially all the functionality of the classification is here in this file, viewcontroller.swift. But what I really want to talk about is this ML model here. So this is the core ML model, which is generated from the model that we have saved here. And the way that we convert this H5 file into an ML model file that Xcode and Apple can use is with this script here, convertModel.py. So let's have a quick look at this script. It's really simple. We just import core ML tools, and yeah, it's as simple as loading in the model and converting it. So let's open the terminal just now, and let's run that. So as long as there is a first try.h5 file in the same directory, it should work. So yeah, you can see here the layers that it's converting, and then we get the saved ML model here. And then it's just as simple as dragging this ML model into Xcode, and then we have our machine learning model in the app. Now let's take a look at the functionality of the app itself. Okay, so here we are in my iPhone now. So we're just going to head over to the Knot Classifier app, and here's a desk. So yeah, notice when we place the app on the desk and there's complete darkness, the percentages are really low, so it's only thinking it's an overhand knot with 12% certainty. Now we show it an overhand knot, and it's classifying its top prediction as an overhand knot, so this is good to see. And furthermore, if we rotate the camera, it will still think it's an overhand knot. So this verifies the data augmentation techniques that we used during training. Now if I put the phone back down on the desk, I'm currently tying a reef knot. So yeah, so there's the reef knot, and now, thankfully, it's giving about a 95% accuracy, 95% certainty that it's a reef knot. And again, if we rotate the phone camera, we can see that it's still classifying that knot as a reef knot. And now if we rotate the knot itself on the z-axis, like we did with our augmentation, we can see that it's still fairly confident with about 90% accuracy that that is still a reef knot. Okay, so now I'm currently tying a figure 8 loop. Okay, so it's interesting that when we show it the whole loop, it doesn't quite classify it as a figure 8 loop, but then when we zoom in to the knot itself, it does classify the knot correctly as a figure 8 loop. Now this is really interesting because it shows that the classifier has actually learned the knot topology itself rather than just memorizing, oh, a figure eight loop has a loop. So it's really cool to see. Okay, now we'll tie a fisherman's knot and let's see if it classifies it correctly. So yeah, when we zoom in again to the knot itself, it's correctly classifying this as a fisherman's knot. And once again, upon rotation, it's still confirming that it's a fisherman's knot. Okay, so now for one final example, we'll tie the Flemish bend. And we can see once again it classifies the Flemish bend as the top knot. And it holds that classification for quite a long time, and once again we'll rotate. This time I'd also like to point out that the second and third classifications are also knots with a similar topology. In fact, with all the knots that have been demoed, the top three choices, predictions, have genuinely been knots with a similar topology. And this is nice because it shows that the classifier has grouped similar topologies together, which is expected. Yeah, so that's the functionality of the app here. And that's essentially all the core implementation of my project. Thanks for watching.